This is AS Module 2, June 07 paper, question 2, and the topic of this question is lenses. The first question, part A, asks us to define the following terms associated with a converging lens. Principal focus. Well, we should all know the definition of this. This is the point through which rays parallel to the principal axes converge after passing through the lens. Just be careful when you're writing that definition. You must say the rays parallel to the principal axes, not just parallel. It must be to the principal axes, and then the word converge must appear in your definition. Then the focal length. This is the distance between the optical centre and the principal focus. Of the lens, and there's one mark for that. Part B then. It is required to use a lens to form a magnified upright image of an object. Should a converging or diverging lens be used? Always converging. A diverging lens will give you an upright image, and it will be virtual, as is the case with the converging, but it will always be diminished. Therefore, it must be a converging lens to get a magnified image. On the diagram below, draw a diagram to show the position of the object O and the image I. Show the paths of the rays and any construction lines you use. Label your diagram appropriately. Well, if we want to have magnified and upright, then our object must be placed between F and the optical centre of the lens. For completeness sake, we know it's a converging lens, therefore we'll draw our arrows to represent that. And we should put the object at any position between F and the lens. And don't make it too tall for the sake of completeness, to ensure that it fits in the diagram. So the object is O, and we always draw two rays. First one, we'll draw parallel to the principal axis, and it converges and passes through F. And remember our arrows. And we know that we're forming a virtual image, therefore we'll continue our virtual rays using a dotted line beyond the left hand side of the lens. And the second ray that we can draw to help us locate the image is from the top of the object through the optical centre of the lens, and there's no change in direction as it passes through the optical centre, and then we continue our ray behind as virtual. This then gives us a point where the rays cross is where our image is formed, and we label that I. And of course we must have arrows on our rays. The marks in that question, the first mark was for locating the object between F and the lens. Second mark was for one of the rays. Third mark was for the other ray, and the fourth mark was for locating the position of the image. If you had no arrows, you lost a mark. And if your virtual rays were not dashed, you also lost a mark. So whilst it's easy to learn and draw those diagrams, it is very easy to throw away marks, either in haste or being careless in exam. And finally, for that part of it, state whether the image formed is real or virtual. Well, we've already drawn virtual rays, so our image is virtual. Moving on then to part 4 of that question. The lens has a focal length of numerical magnitude 10 centimetres. The magnified upright image is to have a magnification of 5.0. Calculate the distance from the lens at which the object must be placed to achieve this magnification. So we're looking for the distance from the lens. So we know F here is 10 centimetres. We know M is 5.0. To do this, M is image distance over object distance, and we know the magnification is 5, so 5 is equal to V over U. We don't have any other information, but we can rearrange that to say that 5U is equal to V. Then if we substitute that into the lens law, 1 over F equals 1 over U plus 1 over V. Then if we substitute that in to say 1 over 10 for the focal length is 1 over U plus 1 over minus 5U. And we use minus because it's a virtual image. So we must substitute the minus there to show that that's virtual. When we continue on that calculation then and rearrange it, we find that 1 over 10 is equal to 5 over 5U minus 1 over 5U, which gives us 4 over 5U. And we can eventually then say 10 equals 5U over 4 by turning both sides upside down. And eventually we get to U is 8 centimetres. And let's just check our question. Calculate the distance from the lens at which the object must be placed to achieve this magnification. And it's 8 centimetres. In terms of marks for that question, you get 1 for substituting in the magnification, 1 for substituting into the lens law, and the final 1 for calculating the object distance.